Okay, this is the second problem for your homework that I'm going to do, and it's this I-beam whose left end is clamped and it is sagging under its own weight. Now, see, now this is from chapter 5 of your book, and I'm not using, when I do it initially right now, I'm not going to use any planes of symmetry, but then quickly I'm going to come and redo this thing with taking a plane of symmetry which is along the length of the beam. Now keep in mind that because this is sagging under its own weight downward, there's only one plane of symmetry. There are no other planes of symmetry. But if this was clamped at the left end and some other load was applied so that, for example, it makes it only axially elongate, no bending, then there will be other planes of symmetries involved. But that is not our case. Okay, so let's go ahead and make this. On a convenient plane, on this vertical plane, I will draw that I-beam that I want with the dimensions. However, what I'm gonna do is I'm gonna draw it symmetrically so that later on I can cut it to model it also using planes of symmetry. So let's first of all, let me make something like that. Dimension these things. So this is half an inch, 0.5. Okay. Now these other things, this is quarter. This is a quarter of an inch, 0.25. And this also is quarter of an inch. No, I'm sorry, that is half an inch. This is 0.5. Oops. Let me zoom in and see what I've done here. Okay, so drag this thing there. Right. Okay, so let's give it another dimension here. I believe this will be 0.25. Yeah. Okay, so this has to be, I'm going to mirror this thing several times so that I get the entire I-beam. Let me see now here. Mirror, let's see now. This, control, that, control. Oh, I guess I have to do this thing one at a time. Okay, that's fine. Let's try it. Mirror this with respect to that. Mirror this with respect to this. And that edge with respect to that. And this with respect to this. It was easier if I actually did all of these with respect to that axis. Okay, so you know what? Actually, I'm going to leave it like this. Show you why. Exit. Let's actually close this bottom because I can't pad it like that. So I'm going to close this profile right there. Okay, exit. Pad it. Where's the pad? Right there by 10 inches. And now I'm going to mirror this whole thing with respect to the XY plane. Remember, later on I'm going to come and cut this, not immediately, but so it's crazy the way I did it. So mirror with respect to XY plane. There we are. Okay, good. Later on I'm going to cut it with the YZ plane, so along this length, but leave it the way it is right now. So apply material, metal out of steel, say OK, save it. Save as, desktop, new folder, I-beam, under gravity, self-weight, gravity, loading, excuse me, let me say OK. Alright, we will now go ahead and go to generative structure analysis. Nobody solves this problem with solid elements unless, you know, there's a purpose behind it. This is a gigantic element, so actually let me make it smaller. These are thin-walled structure, what should be done very carefully. And okay, linear is fine. Let me see how it looks like. Okay, so that's maybe more reasonable as well. One has to be careful because there is a thin flange and a thin uh, uh, web involved. So one has to be very careful. All right, good. So this end is clamped. Where is the clamp? Right here. This face is clamped, and the load is coming from acceleration in the direction z, negative z. So where is that acceleration business? If you look at the loads toolbar, which is right here, where you use pressure and force and things like that, there is an icon here which shows you a web, or not, a globe with a downward arrow. This is acceleration, linear acceleration. And it really doesn't matter what you picks the entire body, okay, because gravity or weight is a body force, and in the direction z, negative, if you know what it is in inches per second squared, you can put it in minus 360. If you don't know, just put down minus 9.8 meter per second squared, and it's going to convert it to this unit. Second squared looks like that. Okay, so right there you can see that. So first of all, save file, save management, save as. Now in that folder, that's the correct folder, and okay, and let's run it. That's all. There's nothing else to it. It's just that you have to know how to apply gravity loading, or as a matter of acceleration. This could have been in the outer space, could have been attached to a space station, which is suddenly accelerating. There's no gravity here, but there is an acceleration that can be specified in a given direction. Right there, you can see that. All right, and if you look at the von Mises stress, the biggest is going to be at the wall because of the fact that this is basically a cantilever beam which is bending. These patches here means that the element is too big. One has to be careful with this. Now the next thing I want to do is to go and create model only half of this, which is fairly straightforward. If you go back to your model here, sit in the background, and if you cut it with the YZ plane, then you need to take only half of it. So here's a split, YZ plane. Doesn't matter which side you pick. So this is my model, and then now when I go to my analysis file right there, if you look at the mesh, all right, you see that half of it is meshed. You can see the only thing that's listed. Well, first of all, this, you see that this residual is because we already had the right hand side, which has now disappeared. Well, that's okay. If you go here to the, where is that, under the load, and just double click on it, it readjusts it so that it knows that there's only half of the piece present. So let me deactivate my mesh. The only thing you have to do, and don't forget, this has to be a surface slider. Without it, there's a major point deduction. Okay, you don't just cut the object and pretend that there's nothing acting on that artificial surface that you have created. For the case of solid, surface slider is going to represent that plane symmetry. Run it again. Forget about the warning. And now if you look at the deformation, where is that? Von Mises stress right there, and change the material shading. Yeah, same kind of thing. We did not have to model the entire object. We needed to model only half of it because there's nothing we gain if we create the second piece. Now these numbers are very tiny because really this is very small, because this is a fat, thick piece of steel which is hanging on under its own weight. There's going to be extremely small deflection, and therefore extremely small pressure or stress. Okay, hope this